Let's do a little bit more practice with our trigonometric ratios or trigonometric functions. So here we're asked to find the values of cosine of theta and sine of theta. So let's start with cosine theta. What is the cosine of theta? Where theta is this angle right over here, and it is indeed a right triangle. So I'll give you a few seconds to think about that. Well, to answer this, you just have to remember the definitions of the trig functions. And to help us there, we'll use the mnemonic SOHCAHTOA. SOHCAHTOA. And the part of SOHCAHTOA that relates to cosine is the ka part. This defines sine, that's why we have the S. This defines cosine, that's what starts with the C. This defines tangent, that's why it starts with a T. So if you look at ka, it says that cosine, let me do it in that same color. It says that cosine of an angle is equal to the adjacent side over the hypotenuse. So in our example here, what is the adjacent side? Well, if we look at it, it's the side that's next to it that is not the hypotenuse. This side is next to it, and it's not the hypotenuse. This side up here is next to our angle, but it is the hypotenuse. It's the one that's opposite. It's opposite the right angle. So this is the hypotenuse up here. This is if we're looking at angle theta, this is the adjacent side. And while we're at it, if we want to think about the opposite side, we don't have to deal with it for cosine, but it doesn't hurt to label it right now. That is the opposite. And this is relative to angle theta. So with that out of the way, we said cosine of theta is equal to adjacent over hypotenuse. Adjacent has length 4. What is the hypotenuse? Well, we know what side is the hypotenuse, but they haven't given us the length yet. But we can figure it out using the Pythagorean theorem. We have two sides of a right triangle. We can always figure out the third side. We know that the sum of the squares of the two shorter sides will be equal to the square of the hypotenuse. So we have 4 squared plus 7 squared. 7 squared is going to be equal to, I'll just call it 8 squared, or hypotenuse squared, is going to be equal to 8 squared. So 4 squared is 16. 7 squared is 49 plus 49. It's going to be equal to 8 squared. And let's see, 16 plus 50 would be 66. 16 plus 49 is 65. So this right over here is 65. H squared is equal to 65. Or we could say that h is equal to the square root of 65. And it doesn't look like there's any perfect squares in here. 65 is 13 times 5. Neither of those are perfect squares. So this is about as simplified as we can get this radical. So the hypotenuse is equal to the square root of 65. So in this case, cosine of theta is equal to the adjacent side, which has length 4, over the hypotenuse, which has length square root of 65. Now let's do the same thing with the sine. What is the sine of theta going to be? And I'll give you a few seconds to think about it. Well, so tells us that sine is equal to opposite over hypotenuse. In this case, relative to angle theta, the opposite side has length 7. And what is the hypotenuse, or what is the length of the hypotenuse? Well, we just figured it out. It is the square root of 65.